Hi everyone, my name is Kritika Shrestha, and today we, the group of 4 team members, will be presenting on the UNLV Solar Decathlon 2020 project. We are a graduate student at the Department of Civil and Environmental Engineering and Construction at the University of Nevada, Las Vegas. The project has been completed under the instruction of Dr. Jin Ouk Choi. Moving on, when we talk about the project objectives, the main objective of the project was to develop a class 3 baseline structure and that complies with the S38R06 schedule basis standards. And in order to achieve this, we incorporated all the project constraints and planning assumptions, documented our scheduling logics and methodology, and they aimed all to meet the 30 evaluation metrics. And when we talk about the basic overview of the project involves the construction of the 10 single family residential units, and it is located at the UNLV Paradise campus in Las Vegas. And since Dr. Jin Ouk Choi is the owner of the project, so we 4 team members, we are acting as a general contractor of the project, and the notice to proceed is scheduled for September 2nd, 2025. And the main scope of our project includes the site preparation, building constructions, and interior works. When we look at the contract scope, there are basic requirements that we needed to follow, which includes reviewing the Las Vegas regulations and procuring the materials and equipments, assembling the modular units, and performing the systems and testings. Moving on, when we look at the logistics of our site, it is structured in a way to support the safety and the efficiency and the smooth workflow throughout the constructions. So when we look at the entry gate, it is located at the southeast part of along the box street that allows the control access and a direct route into the sites. And when we look at the location of the crane, it is positioned in such a way that it maximizes the reach into the module installation areas while still avoiding the swinging all over the public streets. And when we look at the laydown area location, it is directly located at the south of the crane that minimizes the material handling and supports the efficient lifting operations. And the module installation area, it is located on north side of the site, and which also provides a large and unobstructed workspace, which is ideal for assembling the module components. And when we look at the other areas, such as the storage, parking, soft spaces, sanitary facilities, and the dumpsters, they are arranged to ensure the safe circulations of the workers, vehicles, and the equipment. So when we look at the organizational breakdown structures, as I mentioned earlier, that our scope in this project, it is limited to construction, as we are acting as a general contractor. And because of this, our contractual relationship, it follows a typical design bid build structures. And in this model, only our direct contractual relationship is with the client and who provides the design documents. So we do not communicate directly with the designers, and which is the characteristics of the design bid build delivery methods. And since we're responsible for material procurements, and we maintain a direct communication with the various suppliers, and we also maintain the communication with the internal coordinators within our project group, such as the project manager, construction manager, field engineer, superintendent, foreman, labor crew, along with all the people who are involved in the project. So it helps to define the scope of the project and the project objectives. And this organizational breakdown structures, it helps to maintain a clear line of responsibilities, and it also supports the efficient project execution. So when we move on to the work breakdown structures, we adopted an approach that reflects the modular nature of the project. And because many modular components, it can be constructed concurrently, we do not follow the traditional bottom-up sequence, and instead the WBS, it is organized by a building components and the major construction phases. As you can see, for the level 1, it represents the overall building. For level 2, it captures the major phases that is associated with the modular construction, such as the module fabricators, transportations, installations, and interior completion. And for the level 3, it outlines the specific activities within each of the project phases. In this slide, what I have created is the 3 levels that helps to create the distinction with the colors, as using the various shades of the blue, and with the darkest shades representing the level 1, and with the lightest shade of the blue, it represents the level 3. I would like to pass to my friend Jacob for the further presentation.
For this project, I worked on scheduling everything into MS Project. I started with a template for a single house construction and modified it to fit the needs of our specific project. Then, once I had all the activities for one house, I was able to duplicate it to get our 10 houses. My next step was to get the houses to be worked on concurrently to speed the project up and to increase efficiency. I made it so that once the foundation for one house was complete, the foundation for the next house began. Then the rest of the activities fell in line, given the logical order of house construction. A challenge I faced, however, was when I assigned the resources. There's a lot of overlap for certain resources such as the inspector or electrician, so I had to level all of the resources, which pushed the project finish date back. Here is a snippet of the whole project. Each house has all their activities under summary tasks that I'll explain later. As you can see here, though, most of the houses take 66 days to complete, with the duration getting shorter for the last houses, since resource overlap isn't as common. The current reporting date of November 25th, the first house is nearly complete at 88%, the second house is at 71%, third is at 51%, fourth is at 23%, and the fifth house just started and is at 4% complete. The total slack for the first house is largest at 82 days. Since the activities after the framing and foundation are not on the critical path, they can be delayed without affecting the construction of the 10th house, which follows the critical path. Here's the Gantt chart for the condensed schedule. Since the activities are minimized, we can take a look at the summary tasks as shown with the brackets to see how the activities are overlapping. The green line represents the current reporting date, and the red task indicate the critical path. Project is estimated to end on July 2nd of next year. As you can see, a lot of houses are being worked on at the same time. There's a lot of overlap, so that was the problem with the resource. So here are all the activities in the schedule for one house. I chose to show house 2 as an example to demonstrate the predecessor relationship modification that the rest of the house also followed. The first task starts with order framing, where it'll only start once house frame 1 is delivered and installed. This is because the fabricator can only work on one frame at a time and can't be installed until the foundation is ready anyway. Following the WBS, we work on foundation and framing, then the dry-in, which actually hits one of our milestones, then exterior finishes, utility rough ends, interior finishes, and then we finish in utilities and do more interior work, install appliances, light fixtures, and once we do that, then we actually hit another milestone, the mechanical completion, and that's basically like where we leave off that house until the very end where we clean up and you need to do the punch out. Next up is our Gantt chart for the entire project. As you can see, it's very large, but you can see how the start of each house begins shortly after the start of the previous house. The critical path after the reporting date is also shown here. It follows the framing and foundation of each house until we get to the last house, and then it follows the activities more closely until the end of the project. I'll pass it off to Fernanda now.
Overall, the schedule brings together our key dates, risks, assumptions, and everything that can impact the flow of the project. I'm going to present this now. Starting with our key dates, the milestones we're working with are notice to proceed, apply for permits, substantial completion, and final completion. These dates set the rhythm for the whole schedule. We also had to consider things like holidays and weather. Nothing too extreme, but enough to impact available work days. Talking about main issues we may face, one of them is site congestion, especially when several trades start working close together. Another big one is inspection delays. Anytime the inspection gets held up, it creates a domino effect. Weather can also interfere with the exterior activities, and of course, crew availability always plays a role in keeping the schedule on track. Talking about risks and opportunities, the risks include crew shortages, inspections that could take longer than expected, and trade stacking. However, we also have positive opportunities. If the crew remains consistent and if we're able to overlap certain activities, we can gain time in the schedule. The idea is to keep enough flexibility to take advantage of these moments. We had to set a few assumptions too. So we assumed that materials and crews would be available when needed, that inspections would stay within normal timelines, and the calendar and weather would behave as expected. Finally, we list what's excluded from the schedule so the scope stays clean and clear. This includes landscaping, road and parking areas, and any off-site work. So these items weren't considered in the timeline, and there was no exceptions. Kiran?
Going to present the schedule evaluation report of our town project. For this, we evaluated 30 quality schedule metrics as shown in the table. And we can see that every 30 metrics has their own threshold values given on the table. So this value serves as a benchmark for the evaluation and comparison, and any breach of which may require a review of the project schedule plan. These metrics are used to assess the reliability and integrity of the schedule plan, and are also used as a basis for the analysis like on-value analysis. Further, these quality schedule quality metrics are used to assess the progress, performance, and the evaluation of the project. Also, project managers use these metrics for the decision making and predicting project outcomes. So this table shows the result of our evaluation of the proposed schedule plan. Initially, we were able to make 21 metrics pass out of 30 metrics as shown in the table. And this shows like 70% metrics passing rate. So it required a review of our proposed schedule plan. So therefore, after making some changes and doing some necessary changes to the schedule metrics, we were able to pass 28 out of 30 metrics, 38 metrics, and this is like 93.33% metrics passing rate. So we can say that our proposed plan is reliable and can be used to assess and monitor the project, and also can be helpful for the future analysis. And if you have any questions, you can contact any of us. Thank you.